For this part of the experiment, I dropped a meter stick from the 0 mark right above the participant's hand. They were unaware of when exactly I would drop it, so they would have a genuine reaction. To measure the distance, I measured from the point at which the crease of their fingers had ended up when catching it. I measured this in centimeters. I had each participant catch the meter stick 10 times in order to run a valid experiment and to be able to calculate an average. Based on the trials, Hunter had an average reaction time of 0.219 seconds, and the average distance the meter stick fell was 20.03 centimeters. Sammy had an average reaction time of 0.181 seconds, and the average distance the meter stick fell was 24.78 centimeters. Callie had an average reaction time of 0.196 seconds, and the average distance the meter stick fell was 14.32 centimeters. Lauren had an average reaction time of 0.198 seconds, and the average distance the meter stick fell was 21.16 centimeters. Nicole had an average reaction time of 0.149 seconds, and the average distance the meter stick fell was 20.85 centimeters. Since we have the calculations for average distance and average time, one thing we can find is the average speed. The equation for speed is distance divided by time. So I will be taking the average distance for each person and dividing it by their average time. This will give us the average speed of the meter stick at the moment it was caught. So for person number 1, their average time was 0.219 seconds. The average distance was 20.03 centimeters. So now I'm going to plug that in. Which gives us an average speed of 91.46 centimeters per second. I will continue doing this for the rest of the people.
Perfect.
Another calculation we can do with our data is the reaction time given the average distance and acceleration due to gravity. Due to human error, the reaction times that I got may be a bit off. By using the formula, t for time equals the square root of twice the distance, so I'll be using the average distance for each person, divided by acceleration due to gravity. That should give me what the actual reaction time should have been. Since I'm using centimeters for my average distance, I can't use 9.81 meters per second squared for gravity, so I'll be using 981 centimeters per second squared for gravity. So for the first one, time is equal to the square root twice the distance of 20.03 centimeters divide that by 981. So we get a reaction time of 0.20. I'm just going to do the same thing for each of my other participants. The last calculation I'll be performing is for percentage error. Percentage error, this is the equation here. So it's VA, which is the approximate value, or in this case, it's going to be the average time found when using a stopwatch. We're going to subtract the exact value. In this case, I'll be using the value that was found for time by using the equation we did in the last part. And it's all divided by the exact value. And we're going to take the absolute value of that and multiply it by 100 in order to get a percent. I went ahead and wrote out all of the equations that I'm going to do, so now I'm going to calculate them.
Perfect, perfect, perfect,
If we take a look at our percentage errors that we found, we can see that some of them were quite off, and that's due to human error. By using a stopwatch, it's not the most appropriate tool because you have to rely on someone to hit start at the exact moment that you're letting go of the meter stick and to hit stop at the exact moment that the person catches the meter stick. So for the percentage error, we can see that for Hunter and for Lauren, it was under 10%, which is generally accepted and said to be good. However, for Kelly, Sammy, and myself, the error ranged from 14% to almost 28%. So that's a big difference. When doing calculations, we want to make sure that they're as accurate as possible.